Hey guys, my name is Andre, and I'm making another STEM video for our outreach. I'm part of the Rigatoni robotics team at the Woodlands High School. We're making a series of videos teaching important science technology lessons. This video is going to be on the atom. Okay, so the atom is essentially often called like the building block of all matter. Everything that exists in the world is built up of trillions and trillions of atoms. I have this, for example, I have this pencil. This pencil alone is going to be made up of many, many atoms, very small pieces that are all connected to form everything in this pencil. Different types of atoms make up everything. It's all atoms. And if you were to take an atom and zoom in on it, which is extremely difficult considering how small they are, but if you were to zoom in on it, you would see that it has three different pieces. It has this piece that is on the outside called the electron, shown in green here. This one is proton. This is the neutron. Get into those more in just a little bit, but that's just kind of a very basic overview on the atom. Okay, so now let's talk a bit about the structure of the atom. So at the center of the atom, in this circle right here, this is called the nucleus. The electrons spin around the outside of this nucleus. Now it's shown in here that they're spinning in these circles, these like orbits around the nucleus, but that's not quite correct. Electrons move very, very, very fast, and they're also extremely small. They're so small and they're so fast that you can't really predict where they're going to be at any point in time. So we often simplify it by showing these loops, but in reality, the electron is spinning in a certain area around the nucleus, but we're not exactly sure at any specific time where it is. So this is a bit of a simplification. So those are just the two basic parts. We have this nucleus and then the electrons on the outside. The area where the electrons are spinning is the entire area. It's called the Electron Cloud. So now let's talk about those particles. So first off, we have the proton. The proton is sort of the identifier of the atom. It's a positively charged particle, and it's located in the nucleus. The amount of protons is what makes that atom a specific element, and we'll talk more about that later. So now let's look at the electron. The electron is the smallest particle, and it is outside in the electron cloud, like I said. It spins around very fast in these, what we call orbitals. So electrons, like I said, spin around very fast, and we're never completely sure where they are. We can make estimates, but we're never exactly sure at any point in time where they are. Usually, an atom will have the same amount of electrons as it will have protons, and if it does, then it's a evenly charged atom, because an electron is a negatively charged atom. If you remember, proton is positive, electron is negative. So an atom will like to have the same amount of positive and negative charges, so those cancel out and make even. This isn't always true. This is a bit of a simplification, but it helps at a basic level to make this simplification, so you can assume that if there's this many protons, then there's this many electrons. Finally, the neutron. The neutron is in the nucleus as well. It does not have a charge. It is a neutral particle, like a neutral subatomic particle. It is about the same size as the proton, which is much, much larger than the electron. So proton and neutron are about the same size. Electron is much smaller. Neutrons usually just are talked about when you're talking about the overall mass of the atom. So a neutron will add mass, but it won't charge like how the atom reacts, because it's not a proton and it's not an electron. It doesn't have a charge. So now let's talk a bit more about the different varieties of atoms and how they're shown in the real world. So you might have seen this diagram before. This is called the periodic table of elements. This has all the known combinations of protons, electrons, and neutrons that make up different atoms. So each of these is a completely independent element. There are 118 of these, but only 92 of them are naturally formed. So 92 of them can be found outside in the earth, and all of the rest have to be made in a lab. So let's look at one of these and break these down. So let's say we have this one. This is nitrogen. This 7 up here in the corner, this is the atomic number. This means there are 7 protons. So earlier, I said that the proton was the identifier of the atom. This was what I was referring to. So an atom, what element an atom is completely based on how many protons it has. The amount of protons in it isn't going to change. Electrons can come and go into the atom. They can leave. They can come back. Electrons are always moving about, and this is what creates reactions. That's a whole nother subject that we can't really get into here, but just take it that electrons can move about in an atom. They can move out of an atom. They can move in it. Protons won't. Protons are what identifies that atom. So if it has 1 proton, it'll be a hydrogen. If it has 2, it'll be a helium. 3, lithium. 4, beryllium. 5, boron. So on, so forth. You can't really add or take away a proton. It happens, but that's a higher level, so we're not really going to talk about that. Just take it that an atom will have as many protons as it has. So that's atomic number. The letters on it is just the atomic symbol. It just correlates to what that's actually called. Usually, the symbol will be the first letter of whatever element that is. So B, boron, C, carbon, N, nitrogen. If not, it might be the first 2 letters with the second not capitalized, like Li, lithium. Sometimes it can't always be like that if it's already taken. So you have examples where it's W, but W is tungsten. You just sort of need to memorize these over time. The more you work with the periodic table, the more you'll start to just know these. Usually there's another number, which is somewhere in this each element box, called the atomic mass, that shows the entire mass of the element, protons, neutrons, and electrons. You can pretty much ignore electrons, though, considering they're so small. They weigh pretty much nothing. So it's really the weight of the protons and the neutrons combined. So you see these are different colors, right? These are different sections of atoms. At a low level, you don't need to know all of these. Just know that this first column right here, these are called the noble gases. These do not react. It's a bit more than I can get into why, but the amount of electrons they have correlates with the amount of protons they have. As I was talking about earlier, that's what an element wants to have. These elements don't want any more electrons. They're happy as they are, so they don't react. The noble gases. Then over here, these are called the halogens. These are usually very reactive. These are just some other non-metals. Into around this area, you're getting into the metalloids like silicon, or germanium, aluminum. These are metalloids. They have some property of metals. They have some properties of non-metals. They're kind of in between. Once you get down here, you're getting into the metals. They're separated here. These are just different types of metals, but these are all your metals. You have Ni, nickel, Cu, copper, Fe, iron, your metals. And then over here, these are more different sorts of metals. These are called your like alkali metals and your alkali earth metals. This is where you have like lithium, sodium, potassium. These usually don't have quite the same traits as the metals that we often commonly known as, but they're still considered within chemistry to be a type of metal. So those are just some very basic things about the periodic table. This is, if you start to take classes in chemistry and stuff, you're going to see this pretty much every day, every class. It's all about this. This can go incredibly complex, so this is just a very basic overview, but I hope you know a bit more about atoms and the periodic table now.